So everyone, my name is Mohammad Sharif bin Parvez. I'm the managing director of the Pro Skills Trainings, and we will start our session now. I hope that this session will be a fruitful one, and every one of us will learn something new. And I want this to be very interactive. Like in the end, I want the feedback from all of you, like so that we can improvise. So next time when we are doing our session, we can improvise those sessions. So all right, Sanjay, I'll start now.
Yeah, please go ahead, Chef. Yeah, I can hear you well. Please go ahead.
All right. So Pro Skills, it's a Saudi company. It's specialized in training, consulting, and advisory. So I'll go briefly about Pro Skills, then we will start the session with Sanjay. So Pro Skills is the first authorized training facility of Big C in Saudi Arabia. We are the first one in whole Middle East, Africa, and Europe. We have multiple cutting edge programs, state of the art facility. We have expert faculty. Then these are the learning path. These are the certifications of BICSI that we are providing. BICSI is like a governing body which makes standards for data centers, ICT, IT, and there are multiple other things like installations and technicians also. They do provide the trainings as well. So this is the first training called the Installer 1 training. Then after that, there is an Installer 2 training that is related to copper, and there is another one for fiber as well. Then the third one is called a tech training. It's a complete training. It has each and everything, not only copper and fiber. It has grounding and bonding. It has fire stopping, all those things that are required in ICT and telecom. Then the next one that we have is the RTPM, Registered Telecommunication Project Manager in BICSI. Then we have outside plan designer, data center design consultant, and the RCDD, the biggest one. Last week only we finished one session for the RCDD training. Next, we have Fluke certification training as well for the testing of the copper and the fiber cables, like how the copper cables and the fiber cables should be tested and on what parameters it should be tested. It's not a product training, basically. It's a training related to the standards on which copper and fiber cables should be tested. Then something new that, as I told you in the beginning, that we are a niche type of a company. We have specialized training related to the complete portfolio of the ICT, IT, data centers, cybersecurity, and all those things. So we have smart cities, telecommunication courses also. This is about the basic understanding of the telecom systems that is required for the smart city. Actually, we in here in Saudi Arabia, we have huge requirement because of those mega and giga projects. We are also providing 5G, 6G, and cloud trainings also. We have 5G, 6G, Open RAN, I think so. I will leave this to Sanjay. He will explain more about these things. Then we have AI and machine learning trainings as well. So these are some of the offerings that we are offering about these trainings that we offer. Also, we do cybersecurity consulting, implementation, and operation. We have strategy, digital identity, application data security, staff augmentation, managed services, cyber defense, infrastructure, and IoT security. Then this is the portfolio that we are hitting to, and what is our focus is like on the vendors, distributors, system integrators, and end user to provide them the knowledge about cybersecurity, whether it is network security, SOC management, authentication services, data privacy services, security strategies, business resilience. There are multiple other things that, in cybersecurity, there is a huge portfolio. We have a team of experts who can do these things. Then our people and partnership, you will see that most of the companies, most of the certification that is required for a cybersecurity industry, we do have it in our team. We are also doing corporate trainings as well. We are doing communication skills, leadership skills, collaboration, critical thinking, adaptability, problem solving skills, time management skills that are required nowadays for a lot of organization to enhance the quality of their team. Also, we are doing advisory for the design validation, design certification, audit, and design compliances for the data centers, ICT, telecom, ISP, OSP, and cybersecurity. So that is something that we have, and the industry that we are focusing on is like the public sectors, healthcare, oil and gas, travel and hospitality, manufacturing, finance and banking, and last but not the least is the telecom. That is our major goal. So this is our training facility. It's a state-of-the-art facility. You can see behind me as well. This is not a virtual background. This is our own facility, which you can see. So this is, I'll just give a glimpse of our facility to all of you. So this is a complete facility. I would say it's not a facility only, it's a complete lab. So we have all types of tools, testers, and everything that is required to do the job. Not only our focus is not just giving presentation and PPTs. We have that objective, or our mission is to train the people with their hands. They should do it everything by their hand. So that is our mode of training actually. So I will now leave it to Sanjay. He will explain about him, who is he, and what he is doing, and about the session which we come forward today. All right,
Okay.
guys. Thank you so
Yeah,
much.
yeah. Thanks, Af. Thanks for the wonderful introduction, and thanks everyone for joining in. I'm Sanjay Kumar. I'm working as a lead trainer with ProSkills in Saudi Arabia. I'm sure some of you have already interacted with me in some of the previous training programs, right? And this session is going to be, focused on Open RAN and the components of the Open RAN and what kind of job opportunity it brings in, what kind of changes are happening in the network, and we will be talking about all these things. And with that, let me share my screen and let me know once it is visible so that I can get started with the discussion. Yeah, Shaf, do let me know if you're able to see my screen. Shaf, can you please confirm if you're able to see my screen, and I'll get started with this? Okay, great. I can see
Yes, we can see your screen.
Okay, great. So this session is brought to you by ProSkills Training based off Riyadh. I'm Sanjay Kumar, and this session is going to be about Open RAN. We will talk about some components of Open RAN, the way things are happening in the industry overall, right? And the kind of challenges what Open RAN is facing. Currently, there are a lot of discussion happening around 5G, around Open RAN, whether 5G is a success or a failure, whether Open RAN is a success or a failure, and then there are new things coming up with the name of AI RAN, artificial intelligence. There is new consortium which are being formed. Right, we will be talking about all these stories and whether this Open RAN is a promising area or not a promising area. We are going to talk about some pros and cons of this. We will be talking about some deployment status, how the things has evolved over a period of time with Open RAN, how it looks like today, what are the major companies, what are the major players in this industry. We will be talking about all this architecture. Of course, we will not get into the deep dive concepts, deep technical concepts, because we have a limited time. We have just got 50-60 minutes to cover all these things, right? But if you have any further question, please feel free to drop your question to Sharf or to me, right? And we will be more than happy to answer those questions. In addition to that, we are coming up with some classroom sessions in the month of February in Riyadh Training Center, where we will be doing hands-on trainings related to Open RAN, related to 5G networks, etc. And if you are based out of Riyadh or somewhere in Saudi Arabia and want to join those sessions, please feel free to reach out to share for those things as well. Right. Now, moving on, second. Just give a minute. Right. So this session is going to be about Open RAN, as I mentioned. What are the things we are going to discuss here? The agenda for the session. We will start our discussion related to mobile network architecture and components. We will talk about the building blocks of the telecom. Let me just say, stop my video. I think it's consuming too much bandwidth as of now. Give me a minute. Yeah, I think, okay, right. So we will talk about the overall building blocks of mobile network, how the mobile network looks like, what are the typical things we are going to talk about in today's session. And then we will talk about the major standardization and the specification bodies in the overall telecom industry, as well as specific to the Open RAN. We will talk about the evolution of the radio access network. We will be talking about some of the protocol stacks of the 5G NR, which will be split further to make some space for the Open RAN architecture. And that's where we will talk about Open RAN architecture. We will be talking about open-end deployment status, what are the different things which are happening in the industry, how this open-end map looks like from the O-RAN alliance point of view, we will be talking about it. And now, at a data stage, we will be talking about 6G innovation for Open RAN and the way forward, right? So 6G innovation means we have seen that with 5G, there was a lot of discussion around Open RAN, but it did not pick up the way people have expected it. But in 6G, it looks little more promising when it comes to Open RAN. And what is the reason for that? We will be talking about that as well. And finally, at the end, we will have a quick summary and the concluding remark. And after that, we will move to the questions. Meanwhile, in between also, if you have any questions, please feel free to drop your questions in the chat box, and I will be taking all those questions at the end of the session. The recording of this session, if you miss a part of it, the recording of this session will be uploaded on our YouTube channel, and we will be sending a link to all of you. Right. Now, as I mentioned, this is an open session. We will not get into the deep technical concepts. It's going to be a little overview kind of session. If you have any further questions, we can discuss at the end of the session. During the session, please type your questions in the chat box. We will have a Q&A session at the end of the session. And then the video recording of this will be uploaded on our YouTube channel, not the application, and the link will be shared. If you need any further information, please write an email to sharf@proskillstrainings.com or visit proskillstrainings.com to understand our other offerings. Now, let us talk about the overall network architecture and what are the major components of these networks. So this is, being an engineer, we normally start with a block diagram, and this is the block diagram where we can fit each and every telecom network, whether it is a 2G network, 3G network, 4G network, or 5G network. The starting point of the network is the access network, right? The access network, the discussion what we are going to have is more going to be towards access network. And we all know that access network was kind of black box for the operators for many, many years. We have seen the companies like Ericsson, Nokia, Huawei, ZTE, Samsung. They were just giving the box to the operator. That box comes with a purpose-built hardware, with the tightly integrated software. And operators has very, very little choice to play with those hardwares and software, and they did not have any liberty to play with those components of the network. So access network was a kind of closed, kind of proprietary network, and that is what Open RAN is trying to address over the period of time, and that we will be discussing further. However, the access network is not the complete network. We also need to understand that access network is just one component of the network, just one component of the network, which is facing towards the end user. So the connectivity towards the end user, or the access to the network for the user is provided by the access network. So access networks are typically designed to provide you access, not the services. The services are either provided by the core or switching network, or they are passed on to some external network for providing those services. So the core and switching network can have three different domains. They can be CS core domain, circuit switching, which was the scenario in 2G, 3G network, which we will not discuss, of course. We will not spend time talking about the CS core network, or the PS core, which started from the days of GPRS, General Packet Radio Services, and then continued in the form of 3G, 4G, as well as 5G. And in case of 4G and 5G, we have pure packet switching core network or packet core network. Also, the third domain, which is not mentioned here, is the databases, because to provide these mobility, provide these services, we need to bring in a lot of different databases, some temporary databases, some permanent databases, some databases for authentication, some databases for equipment identification, right? So there are a lot of databases required to give you the seamless services across different networks. To connect the equipments within the access network, within the core or switching network, or between the access network to core and switching network, we will need some kind of transport network. Transport network traditionally has been, multiple types of formats. It can be electrical cable, optical cable, microwave, satellites, right? However, over the period of time, we are seeing that a trend which we are seeing here is the most of these the transport networks are merging into the fiber-based IP networks, because the kind of data rates what we are looking at in the transport network cannot be fulfilled by electrical or satellite or maybe microwave kind of communication, right? So basically we are using this transport network as optical fiber network most of the time. I'll not say almost 100% of the times, but most of the times we are using these as optical fiber cables. And nowadays, we are also talking about providing satellite connectivity to the end user. That's typically considered as one of the key area in 5G called as NTN, which is non-terrestrial network. However, we will not get into the details of the non-terrestrial network here in this particular section, but there is some scenarios related to the satellite-based internet connectivity related to the end user. To manage all these network pieces, the access network component, core network component, transport network components, we need some kind of network operation center or some kind of NMS or some kind of orchestrator, right? So basically, these are the network piece of the network which does the monitoring and supervisory of the network. Managing the network, we normally call this as FCAPS, fault management, configuration management, accounting, performance, and security management. So these are the four major building blocks of the network, which includes the access network, core network, monitoring and supervisory network or OSS network, and the transport network. Our discussion today is going to be focused more on the radio access network or the access network part of it. Now, if we wish to look at the architecture of 4G, I have intentionally skipped the 2G and 3G network. We don't want to spend time on that. In case of 4G, the access network, which was typically named as EUTRAN, which was derived from UTRAN in 3G, where the components were called as eNode B or Evol Node B. And then we had something called as EPC or Evol Packet Core, which had components like MME, HSS, SGW, PGW, and PCRF. Of course, there were more components, but we are just talking about the major components here. And all these devices, if you see, they are connected with some kind of one-to-one lines. That means we were defining some kind of point-to-point interfaces, At this stage, we have also started doing few things with the base station as well, where we have tried separating them in two different entities, which are called as BBUs and RRUs, baseband unit and radio units, baseband units and radio units. And we will be talking about these things in the upcoming discussion. But at a high level, these baseband units and remote radio units still used to come from the same OEMs, and they were having some kind of proprietary interfaces. That means you cannot buy the BBU from some other company and your RRU from some other company. You have to buy both the things from the same company, and they will not provide you any multi-vendor kind of network in the radio space. However, there was a possibility where radio network and the core network components can surely come from the different OEMs. In 5G, we have tried to change something in the core network, where we have tried to create an architecture which is called as service-based architecture or SBA. Service-based architecture or SBA, where all the network functions or the boxes which are shown here, these boxes are not actually the physical boxes or the hardware boxes. They were all microservice, a collection of microservices or kind of CNF. CNF stands for Cloud Native Network Function, where I can deploy these services as some microservices in my network, and all these network functions can be created as a collection of microservices, and they are called as Cloud Native Network Function. However, the eNode B is now renamed with a new name called a GNode B, the next generation Node B, where we have just replaced the eNode B name to the new name called a GNode B, next generation Node B, which typically connects to the core network, and in core network connects to the AMF for the control plane and connects to the UPF for the user plane. All our discussion, as I mentioned, not going to be around core network. We will be having some future sessions related to core networks as well. But in this session, our focus is going to be majorly on the radio network part of it. I just wanted to talk about it just to provide the end-to-end picture. And one interesting thing which we are not able to see in this slide is the complete radio network and the core network is nowadays deployed on the cloud native architecture. That means all the components of the radio network, all the components of the core network can be deployed on the cloud native architecture. That is the kind of architecture we are looking at. So even cloud becomes a critical aspect of our telecom network nowadays. Now, to create these standardization, there are a lot of standardization and specification bodies are working together, which are namely ITU, International Telecommunication Union, 3GPP, Third Generation Partnership Project, ORAN Alliance, and the TIP, which is called as Telecom Infra Project. However, there are some new kids on the block, and we will be talking about those new entities, new alliances, new forums in our later discussion. That these were some of the major bodies which are talking about either telecom standards or some standards specific to the Open RAN. Right. Now, let us take an example. The ITU, International Telecommunication Union, majorly focused on telecommunication standard, which was founded in 1865, and they work majorly on the global telecom standards and manage spectrum allocation. They have different bodies under ITU, ITUD, ITUR, etc. And they are actually managing the standards at the global level. The 3GPP, which was originally designed for third generation network. So when we started talking about third generation network, somewhere around 1998, what we wanted to have is we wanted to have a universal body to take care of 3G standards. And that's where under 3GPP, they created a project called as Third Generation Partnership Project. However, this is not really restricted to 3G now, third generation networks now. It takes care of all the technologies starting from 2G till the 5G network. So starting from 2G till the 5G, all the technical standards are taken care by 3GPP, and all these specifications are available on the website of 3gpp.org. So if you wish to look at any standards, any releases, or anything else for that matter, you can just go to 3gpp.org website and you can download all these specifications for free. Right. Now, when it comes to the Open RAN, the Open RAN was actually taken care by two different entities, which is ORAN Alliance and the Telecom Infra Project. The Telecom Infra Project was actually founded in 2016, right? And Facebook was one of the founding member of the Telecom Infra Project. And the whole idea, whole focus of Telecom Infra Project is to create open telecom infrastructure. What was the reason we were looking for open telecom infrastructure? Because there were very handful of the companies who were working in the development and deployment of the telecom network. And they wanted to make it a level playing field so that more companies, the newer companies, can enter into this domain. And that is why they wanted to have open infrastructure so that our network deployments can become more affordable and more accessible worldwide. Keeping that in mind, the ORAN Alliance was formed, which was a combination of two different bodies called as CRAN and XRAN. CRAN was Chinese dominated and XRAN was American operators and OEMs together has built that. And a combination of that came as ORAN Alliance. And the ORAN Alliance started building the standard and specification for the Open RAN. Standards and specification for the Open RAN. And all these standards and specification can be actually can be looked at o-ran.org, a website where you can find all these standards and all the specification related to the ORAN. So ORAN is typically creating the standards for the Open RAN, where Telecom Infra Project takes care of plug fast, interoperability testing, certification of the products which are created by multiple vendors. They organize a lot of events like Fuse. They organize this year they are organized in Dublin. So they bring the industry together so that products or the companies or the startups or the OEMs can work together and build the products which can work with each other. That is the intent of the Telecom Infra Project. For creating those products, the specifications are created by ORAN Alliance. Now, in addition to the ORAN Alliance and the Telecom Infra Project, we also have a Open RAN software community in collaboration with the Linux Foundation. So basically they create some reference implementation of specification. They create open source, open interfaces, RAN intelligence, REC, etc., So a lot of projects which are running. So in our training programs, we actually demonstrate some of these projects in the hands-on labs where we are able to deploy it, able to test some of these, RAN intelligence algorithms, etc. In addition to that, they also collaborate 3GPP. One important point to note here is the ORAN alliance is not there to compete 3GPP. So it's not really there to compete 3GPP. It is just complementing the work of 3GPP. So 3GPP, the ORAN alliance will start from where the 3GPP work has ended. So basically, they adopt all the standards given by 3GPP and then try to add some more things related to the things which are not covered by 3GPP. In addition to that, there is a body which is ORAN Open RAN Policy Coalition, which works with the bureaucrats, which work with the leaderships and the CXOs of the companies or the government bodies, regulatory bodies, to bring the policies, to build the policies around Open RAN. In addition to that, they also work together with the GSMA or HC kind of bodies. Of course, there is a bigger picture which talks about n number of other things, which is not we are talking here. But this looks like the overall architecture of the Open RAN industry and the things related to the standardization. However, there are some new kids on the block, and recently there was another alliance which was formed called as AI RAN Alliance. AI, I'm sure everyone is aware artificial intelligence, but this AI RAN Alliance is basically talking about three things which are called as AI for RAN, AI and RAN, and AI on RAN. Right. Now, what is AI for RAN? What is AI and RAN? What is AI on RAN? Let me just explain these things in one liner. AI for RAN means all the existing application of the radio access network, how they can be made more powerful by using the artificial intelligence. So you have interference management, you have resource allocation, you have policy assignments, and a number of other things which are the existing application of the radio access network, and how they can be made more prudent, more powerful with the power of AI. That is what is taken care by AI for RAN. Both radio access network and the artificial intelligence, both of them require some kind of computing resources. How they can actually create multi-tenancy kind of network or multi-tenancy kind of architecture where the same pool of resources can be used by radio access network, can be used by artificial intelligence. So basically the computing resources which are deployed on the site, how they can be shared among radio access network and artificial intelligence, and that is typically taken care by the AI and RAN working group. The third one, which is AI on RAN, building new applications which are not really the traditional application of radio access network. It may be some kind of new streaming applications. It may be some kind of video optimization. It may be bringing some kind of edge computing kind of applications in the radio access network. So that is typically taken care by another work group called as AI on RAN. So even though this AI RAN alliance looks like it's a very, very new consortium, it has been, been in place maybe around 6 months to 12 months, but this is majorly talking about artificial intelligence along with the radio access network, right? Now, whether they say that they are not really working on any standardization, and they are not even working with the standardization organization, but they say that, okay, the kind of standards what we are building, they can be adopted by the specification bodies like 3GPP or like ORAN Alliance. So this is the statement, the initial statement which came from the AI RAN Alliance. In addition to that, there are a lot of telcos which are coming up together to build something called a GTAA, Global Telco AI Alliance. Global Telco AI Alliance, which comes with the companies like T-Mobile, Etisalat, Singtel, SK Telecom, and they are trying to build some kind of LLM model specific to telecom. We all know that the LLM, the large language models, which are typically the models which are used for created after the kind of different type of generative AI kind of content. We are trying to build similar models for the telco related application, telco related use cases. And this global telco AI alliance is working exactly on the same. So these are some of the new things which are happening in the world today. We are talking about AI RAN in addition to ORAN alliance. We are talking about AI RAN alliance. We are talking about global telco AI alliance, where all these companies coming together to build a larger ecosystem for the artificial intelligence, which is specifically fine-tuned for the telecom related application, telecom related companies. That is where the world is moving today. Now, let us talk about the overview of RAN evolution, and let's have a look at the 5G RAN protocol stack, how the 5G RAN protocol stack looks like and how it is going to migrate or going to move towards the open RAN kind of architecture. Now, if I talk traditionally, I started working in telecom somewhere around 2003, and at that point of time, our base station used to be very bulky base station with a very large racks. The racks used to weigh somewhere around 200 to 300 kilograms. Used to come with lot of cables, lot of back planes. Right now, installing, deploying, commissioning, integrating those racks are going used to be very difficult. Over the period of time, what we have done is we have started moving from those racks to some kind of modular architecture. And this product come from Nokia, which is Nokia Flexi BTS. I'm sure some of you have already worked on it. It used to come with two modules. One is the module, which was the baseband unit called as system module. And then there used to be radio module, which is called as RRM, remote radio module. Nowadays, in general, we can call them as a BBU and RRU, baseband unit and remote radio unit. The good part about these remote radio unit and the BBUs that they are modular architecture. They don't have any backplanes. They are very easy to plug in, very easy to configure. They are just connected with some kind of front cable. The typical weight of these racks used to be somewhere between 200 to 300 kilograms. The weight of these modules used to be somewhere around 20 to 30 kilograms. So basically, they are easier to install, easier to carry, and they were very flexible in deployment, in configuration, in troubleshooting, etc. So there are a lot of flexibility we started getting from the modular architecture, but still the SM and RM, the system module and RR, the remote radio module, you have to buy from the same vendor. So between them, we used to have some kind of proprietary interfaces. You used to have some kind of proprietary interfaces between them. So you cannot buy these boxes from two different vendors. At the same time, the hardware and the software of these components used to come from the system. So the softwares are tightly integrated with the hardware. And that is what changed when we started talking about vRAN or virtual RAN, which we will discuss at a later stage. Now, we also started moving from the shelter housed devices to the tower mounted devices. There was a time when you install only the antennas at the tower. So there used to be feeder cables running from the base station connecting till the antennas on the top of tower with huge losses in the feeder. So at a later stage, we also started installing some of these components on the tower itself, where these can connect to antenna by some small jumper cables, 1 or 2 meter jumper cables, and they are installed very next to antenna. And that will help you to reduce your feeder losses overall. So basically, we have started moving, and at the same time, you need very less space in the shelter. So most of the radio units, they can be installed on the tower very close to the antennas. Now, we also started talking about the products which moved away from the proprietary racks. Earlier, even the racks you have to buy from the same OEM, right? So even the racks you have to buy from the same OEM, but nowadays they have created the product which can be installed into any standard 19-inch rack. So if you want to install a base station, you need not to buy the rack from the OEM. You can use any of the existing vendor. That will save you money. At the same time, that will save you space as well, because shelter space is also a very, very costly space. The real estate is a very, very costly space on each and every base station site. So you can install it on any standard 19-inch rack. You can install it on wall. You can install it on tower as well. Some of the components, if not all. So we are started moving from proprietary racks to the standard 19-inch rack as well. And last but not the least, many of these components, if not all, they have started moving toward the COTS architecture. And that is where we started talking about vRAN, virtual radio access network, virtual radio access network, where the hardware and the software applications were disaggregated. You need not to buy the hardware and software from the same vendor, and that is where we started deploying these applications on some kind of commercial off-the-shelf hardware, and that is typically called as a vRAN. So we have a journey in the radio access network, which is initially called as traditional RAN. Then we talk about DRAN, distributed RAN, and then we move to CRAN, centralized or the cloudified RAN. And then we talk about virtual RAN. And finally, we move to something called as Open RAN, which we will discuss later. So basically, all these components, all these hardwares, they have started moving towards the generic general purpose processing, or maybe GPP kind of hardware or quartz kind of hardware, where you need not to buy the hardware and the application from the same vendor. And that is one of the power of the Open RAN, what we are going to discuss further. And once we are moving to the GPP or general purpose processing, it is not really required to build all the processing on the site itself. Some of the processing part can be deployed on the cloud architecture, which can be a private cloud, which can be a public cloud. Just to take an example, Dish Wireless in US, they have completely deployed their radio network, or completely deployed their 5G network on AWS. So you can build your own private network, you can build it on public network, public cloud as well. It all depends how you want to play your game. So basically, most of the companies are doing it on their private cloud, but some of the companies has also gone for public cloud kind of architectures as well. Right. Now, moving on to the 5G NR protocol stack. Just give me a second. Okay. Now, if you look at it, we have the 5G NR protocol stack, which is not very different from the 4G LTE protocol stack, where most of the layers are same. If you look at the layered architecture, the PHY layer, the MAC layer, RLC layer, PDCP layer. On top of that, we had RRC layer, which is the only layer which is different in the control plane and the user plane, right? So in case of control plane and user plane, the bottom four layers are same. Okay, Maddie says SDAP is missing. No, it is not missing, because SDAP is a user plane protocol, which we will see in the next slide, right? So the RRC is the control plane protocol. And now the PHY layer, which is one of the most complex layer and covers a lot of different details like channel, modulation, channel coding, and a number of other things, and number of other function, what it does, pre-coding, etc. And the MAC layer, which does multiple function along with the scheduling functionality. RLC takes care of retransmission, etc. PDCP takes care of ciphering, encryption, header compression, etc. Of course, these are not the detailed functions I'm talking about. These are the functions at a very, very high level related to these protocols. Even though the NAS, non-access datum protocol, is not really a part of the RAN protocol stack, we have just shown that for the completion, where this NAS protocol or non-access datum protocol is the communication between the UE to the AMF, the user equipment to the access and mobility management function. So these layers, what we see here is the communication between the UE and G node B, and these layers have their specific functions, and all these layers, not all of them, but most of them, they are defined in 3GPP documentation 38 series. So 38.201, 211, 223, 221, 222, all these numbers which are defining some of these protocol stacks in the 3GPP technical specification documents. The only layer which is different in the user plane side of it is the SDAP layer. Now, SDAP layer, Service Data Adaptation Protocol. This is one layer which was not there in 4G as well, which is a newly introduced layer in 5G. And before we move forward, I would like to understand from you guys, if anybody is aware, what is the purpose of using SDAP layer? Can somebody help me to answer that in the chat box? Any of you? Can you please answer what is SDAP layer and what it does? Any answers from anyone? If you are aware, can you please write that? Okay, Hemant says QS negotiable. Okay. Any other answers? QoS, network slicing, handling, okay. Quality of service. Okay, so most of the answer related to QoS, yes, it has some functionality related to the QoS, some functionality related to QoS, where it can help you to map multiple QoS flows. It can help you to map multiple QoS flows to a single radio bearer. So that is what mapping bearer with the mapping QoS flow with the mapping QoS flow with the same radio bearer. That is typically taken care by SDAP layer. So that's the correct answer. In addition to that, between G-Node B and the UPF, we have this GTPU, GPRS Tunneling Protocol User Plane, which is not really a new protocol. It is coming from the days of GPRS, as the name suggests. GTP, GPRS tunneling protocol comes from the days of GPRS and still used till the 5G network. So we use the same protocol which comes from the GPRS days and even continuing the same protocol in the 5G as well. Now, this is something which is we need to understand when we want to talk about the functionality of the Open RAN. Now, what we have done here is, traditionally, when we have divided our BBU and RU, we were mostly using the option 8. And between BBU and RU, we were using an interface which is called a CPRI, which was originally designed as an open interface. So if you look at the name of the CPRI, Common Public Radio Interface, which was designed for an open interface where you can bring the system module from someone else and the radio module from someone else. Unfortunately, the way it was created, it has some space for vendor customization. And because of that, most of the vendor did this implementation as a closed interfaces. And even though CPRI was defined as an open interface, it was never used as an open interface. Right. Now, what we have done here is we have divided this functionality of PHY layer into two parts, low PHY and high PHY. The MAC layer, low MAC and high MAC, low RLC and high RLC. And on top of that, we have PDCP layered, and then we have RRC for the control plane and SDAP layer for the user plane. Right. Now, at this stage, the PDCP, the PDCP and this RLC functionality is broken down, and they have created a new open interface named as F1. A new open interface named as F1, which can be further divided into F1C and F1U, and this specification is created by 3GPP. So the architecture and the details of the F1 protocol are specified by 3GPP, and this is typically separates your PDCP and RLC layer, and this is also referred as option 2. Now, the overall architecture of F1 interface may look something similar. If you look at the protocol messages and the kind of setups, what they do, the kind of communication, what they do, that may look like something similar to NGAP or S1AP kind of protocol architecture. I'm not saying they're same. I'm saying the overall documents, if you see, and the overall setups, what you see, they may look something similar to the kind of architecture what we are using in NGAP or S1AP kind of protocol. However, now we have multiple options to choose from: option 3, option 4, option 5, option 6. And option 6 is one option which is normally used by SCF. SCF, which stands for Small Cell Forum. Small Cell Forum talks about some interfaces like FAPI, FAPI, or NFAPI, Network FAPI. And then we have the most most popular option, which is option 7.x. And normally what we do here is we consider this option 7 and option 2 as one of the building blocks of our Open RAN architecture, where we give this functionality to radio unit, give this functionality to distributed unit, and this functionality is given to the CU or centralized unit. So this is one of the building block, and even the 7.2 is also considered as two different options, 7.2a and 7.2b, with a minor difference in terms of pre-coding. They have slightly different kind of architecture, and that is typically taken care by option 7.2a and 7.2b. They are slightly different. 7.2a is more popular, and 7.2b is for some specific use cases it can be deployed. So this is the architecture what we have created. And when we talk about O-RAN compliant, we also call them as O-RU, O-TU, and O-CU, which means your RUs, DU, and CU are compliant to the O-RAN specification. This is the kind of architecture what we are looking at in the open. Just allow me a second, and then we'll continue. Now, moving on to the open RAN architecture. And this is where we talk about the cloud. The O cloud is nothing but the general purpose processing, the GPP or the CORS hardware. The ORU is the Open RAN radio unit. ODU is the Open RAN distributed unit. The CU, the centralized unit. I'm just facing some problem with my annotation tool, right? The CU can be further divided into two parts. One is called as CP, another one is called as UP, which is nothing but a kind of separation for the control plane and user plane. The control plane and user plane, where the control plane functionality and the user plane functionality of the CU can be broken down into two pieces. In addition to that, we have brought in two new functions here, two new functionality here, which are called as RIC. RIC is called as RAN Intelligent Controller. So we see one RIC here, and we see another RIC here, which is called as near RT RIC and non-RT RIC. The near RT RIC hosts some kind of applications which are called as XApps. The non-RT RIC, which is hosting some applications called as RApps. And in addition to that, we have one another form of applications which are called as distributed apps, which can help you to do the real-time kind of applications, real-time kind of functionality, which can run on DU, CU, etc., right? Which are typically taking care of the real-time functionality. There are some kind of control loops. There are a lot of details what we are going to discuss here. One important point what we need to discuss here is what is the functionality of RIC? What actually RIC is doing? What we are trying to achieve with the RIC? That is one question we need to ask at this point in time. What we are trying to do with the RIC or radio intelligent controller is that we want to bring the intelligence in a centralized location. And that intelligence can be powered by using some kind of artificial intelligence and machine learning. And that's what we are trying to achieve here. Because as long as the intelligence is distributed, right, we are not able to create great insights. We are not able to create great insight in terms of that particular intelligence. But as of now, we are trying to bring in a lot of power for with the artificial intelligence, machine learning, right? And the real power of Open RAN will actually become visible when we see the real implementation of the artificial intelligence. And that can happen when we collect a lot of data from the network, run our ML, machine learning algorithms on top of it, create some kind of trained models, and then pass on those trained models to the near real-time RIC, so that real-time RIC can actually deploy those models in the live network. So this has to be a complete life cycle of artificial intelligence and machine learning. And that is what we are trying to build. That is what we are trying to build by using a new entity called as RIC or RAN Intelligent Controller. So the actual power of the Open RAN architecture doesn't sit in the ODU, ORU, OCU, etc. It actually comes from the near real-time RIC. And if you look at this picture, we also see something called as Y1 consumer. The Y1 consumer connects to the near real-time RIC by using an interface called as Y1 interface. This is another interesting interface. This is another interesting interface where we can actually expose the capability of the RAN, capability of the radio access network by using the near real-time rig, and it can be given to the Y1 consumer. What can be the Y1 consumer? Y1 consumer can be some of the nodes of the core network, or it can be any third-party application which may consume the data of the radio access network. So the open RAN architecture, of course, even though it is at a very, very early stage, we may see a lot of innovation happening in terms of artificial intelligence, building new applications, and I think it is going to get more and more power as we proceed further. Right now, if you see the colors, we have two different type of colors: the green color and the blue color. Right, the green color means all these interfaces are defined by ORAN Alliance. The blue color means all these interfaces are defined by the 3GPP. Now, moving on, 1 second. Okay. Right. Now, let's move on to the next step where we will talk about the open RAN deployment status. Now, if you really want to see some kind of real-time architecture, you can always refer to the ORAN website where they have something called as ORAN map, where they show you some maps. This is typically the various activities which are happening. So that means here that 16 activities are happening. Somewhere here 4 activities are happening. And when you actually zoom in, you will be able to see whether these activities are happening because for testing, they're happening for field trial, deployment, pre-commercial launch, commercial launch, or some kind of memorandum of understanding. They also talk about something called as OTIC, some kind of virtual exhibition, some kind of plug fest which are happening. So this is a latest picture for today, like 2024 December. So this is, they keep on updating all these particular information, and you will be able to see all these information in the real time on the Open RAN website. At the same time, recently, 2 days back, the Mavenir has come up with a report which talks about the overall open RAN ecosystem. And this open RAN ecosystem is actually growing in a big way. It's growing in a big way, right? So there are a lot of companies who are promoting and adopting the open network. There are government which are supporting it, industry alliances which are supporting it, a lot of service providers who are also favoring the open RAN ecosystem. There are companies who are working on the software and hardware components. Okay, so it's already 7:52. Is it okay with everyone if we spend another 10 minutes because I have to cover a few more topics? Is it okay with everyone? Can we just extend our session by 10 minutes? Okay, great. Right, so there are a lot of companies who are working in the space of open radio, in the space of CUDU software, RIC SMO. There are companies who are specifically building XApps or RApps. There are companies who are building the enterprise end-to-end networks as well. And then there are a lot of companies which are actually building the infrastructure, the chipsets, the transmission part of it, the front haul part of it. And then the companies which are doing the job of the system integration, test and measurement, open testing, OTIC centers, etc. So there are a lot of different companies, a lot of different organizations working together to make open RAN as powerful as they can, right? In addition to that, there are 144 organizations in 23 countries which are working very strongly to keep the open RAN momentum high. So worldwide, okay, of course, we will talk about some limitations as well. As we proceed further. So you can see the companies like ACS from Saudi, right? So ACS Saudi, they are also pretty much working on the open RAN part of it, right? So Sandy says, but 10 days back, Mavenir fired 1,400 people. Sandy, I'm not very sure about it. This is happening with most, even Ericsson, Nokia, and many companies are doing it. Apple, Facebook, Google, right? Almost everyone is doing it. So that's a slightly different discussion. And I feel there are challenges, and I'm sure I'm going to talk about those challenges in a short while. What are the challenges which are faced by Open RAN currently? Right. So these are companies which are working on the Open RAN momentum. And then there are a lot of bigger operators like in India, Airtel and VI are also doing some kind of trial. In Saudi Arabia, Gen, or maybe STC, Gen, Mobili, right? How is CloudTrain different from OpenN? So allow me some time. I will try to answer those questions. A lot of companies working here in Europe, in US, like there are a lot of companies, lot of operators who are deploying the OpenN networks and doing the trials of the OpenN as well, right? So this is a brief year-wise breakdown where we talk about what happened in 2018, which actually when the OpenN standards were not even matured, the companies like Rakuten in Japan, which were actually using fully virtualized network, which were actually leading to the open kind of architecture. In 2019, Telefonica, Vodafone, and some other operators have done some trial. And 2020, these companies have extended these trials in the rural areas of UK. 2021, European operators. Okay, so M. Mansal says, okay, let me take this question in a while. Right, so a lot of European telecom like Deutsche Telekom, Orange, Vodafone signed an open memorandum of understanding and started collecting, doing collective work related to Open RAN. In US, the Dish Wireless has started deploying Open RAN as part of its 5G rollout. 2022, there are a lot of things related to Open RAN which are happening in the market, and I'm going to talk about that in a while at the end of the session. In 2022, the Voda, okay, Sandy, I'm not saying you what you're saying is wrong. What I'm saying is there are other aspects to it. So as of now, we are just talking the technical part of it, and a lot of companies are hiring people, firing people. So that is not really the part of our discussion, right? Now, 2022, Vodafone has also extended the open end trials into the urban areas, and also companies like NTT Docomo, KDDI, they also launched some kind of open end deployments. 2023, of course, if you look at some of the recent updates, right, the Open RAN revenues are shrinking. Open RAN revenues are shrinking, and that is creating a lot of stress for the companies, who are working in the open RAN space. And we are going to talk about that in a while, what is happening and why it is happening and how it may happen in the next couple of years. We are going to talk about that when we will talk about the future path for the 6G network and future path for the Open RAN, right? We will be talking about it, right? So of course, some of the recent reports, they talk about the revenues which are shrinking for the Open RAN, and what we are going to talk about those challenges, and we are going to talk about what can be the way forward for the Open RAN, right? Now, this is the section I was referring to where we are going to talk about 6G innovation for the Open RAN. Now, to talk about most of the question what you have asked, can you help me to understand in which year 5G was supposed to get standardized and which year it actually got standardized? Can you help me answer this? Any of you? What was the original plan for 5G specification and when it got actually standardized? Can you help me to answer this question in the chat box? Okay, Sandy says 2020. So Sandy, was it standardized in 2020 or was it planned for 2020? Okay, it was planned. And when actually it got standardized? 2017. So if you look at it, the original plan for 5G was 2020, and actually it got standardized or maybe started standardizing by the end of 2017, and it got frozen in 2018 June. So basically it came with three different releases, three different drops, which was called as early drop, main drop, and late drop. Early drop, main drop, and late drop. So actually it was planned for 2020, it came in 2017. Not to get into exact dates and all, but just to give you a big picture. So if you look at the same time, the ORAN Alliance was formed in 2018. The ORAN Alliance itself was formed in 2018. So basically, the kind of growth what we wanted to have with the 5G network in respect of the Open RAN, the ORAN did not get that time of maturity or get that time to get ready. So basically, when the 5G started deploying in the network, the ORAN specification, the open specifications were not readily available. And most of the major operators of the world, they have started deploying these networks somewhere around 2020, where the ORAN specifications were not even mature enough. And it was not really making sense for the operator to invest their billions of dollars into a standards and specifications which were not pretty mature in the network, right? However, now if we look at the 6G, if we look at the 6G, the 6G is expected in the next decade, which is 2030. 6G is something which is planned for 2030. ORAN Alliance is already pushing lot of stuff with the operator, lot of stuff with the OEM, and there are strong chances that ORAN Alliance, the ORAN standards are going to make a big dent in the telecom network space, in the radio access network, when it comes to 6G. Both 6G and the Open RAN talks about native IP architecture. Both of them, they talk about native IP architecture. That means both of them wants to build those capabilities around artificial intelligence, That is something what is going to be the case for 6G as well as Open RAN. Secondly, if we look at the Open RAN architecture, there were few companies, okay? There are few companies who are working in this space. The first company, which was called as Parallel Wireless, and somehow they faced some headwinds and they were not able to, keep their operations as strong as they were initially. And because of that, they have laid off a lot of people and they were not able to catch up with the time. The other company, which was called as LTO Star, which got acquired by Rakuten and renamed as another company called Rakuten Symphony. And the third company, which is still staying strong, and as somebody said, they have laid off some people, is Mavenir. So as of now, the overall ecosystem in terms of some strong OEM, this ecosystem is not looking that promising on the paper. So as of now, like I see that Open RAN industry ecosystem is looking not that strong, the way we have expected it. And that is one of the reason that Open RAN is not really seeing the progress today what we were expecting. But at the same time, we need to understand that the way we are looking at 6G, which may come somewhere around 2030. I strongly feel that the Open RAN is going to make a big dent in the traditional RAN business if it is able to stay afloat, if it is able to stay strong till that point of time, right? And I'm sure that is going to happen. Open RAN, or maybe Open RAN in another form, I'm not very sure about it, but it is going to play a big role. When it comes to the 6G deployments in the future, maybe 5 years, 6 years down the line. Now, the another interesting point is telecom networks, they always see this kind of trajectory, right? So they have a time when we start creating the standards, and after that, it is all coming down, right? And we have seen this not first time, not second time, but multiple times in 2G network, 3G network, 4G network, and even 5G network. And currently, we are in this phase of 5G network. Not only Open RAN, even the 5G networks are not seeing a lot of traction. And that is also adding to the pain of the Open RAN industry as well. So it's not only the Open RAN who is facing the challenges, it is also the 5G as a bigger technology is also facing these challenges, right? And by the time we move to this particular direction, when we start talking about 6G, I'm sure the Open RAN is going to pick its pace, and a lot of new companies, a lot of new OEMs will also start playing their role into this particular part of the industry. Just to bring to the 3GPP evolution happening towards 6G, right? So the 6G, recently they have launched a new logo for 6G as well, 3GPP, and we are expecting the release 21 timelines release 21 timelines, which should be finalized by June 2026. So we are expecting the 6G timelines, which is going to happen in release 21 in the June 2026. And now we are also talking about the similar timelines for the 6G. So by the time 6G products getting into the shape, the ORAN specification are also going to be ready. So we have already started talking about OpenRAN 6G pre-study research, OpenRAN 6G research study, and then we are talking about the ORAN specification as well. So that is the reason I'm saying the ORAN Alliance or the OpenRAN in general is going to make a good progress when we start with the 6G products and the 6G deployment. Now, with this, we are done with the session. We are just talked about most of the topics what we were supposed to talk. Let me look at some of the questions. And then we can open our floor for the questions. Give me a minute.
Thank you all for joining us. There are multiple sessions. We have limited time, so we just try to squeeze. It's a very huge topic. There is a huge training actually for Open RAN we do have in our portfolio. So if you are interested in one of them, do let me know.
Okay.
I'll
So,
share my contact with you.
just let me take a couple of questions in the
All
chat
right,
box.
all right.
Right. So just a couple of minutes, and then we can actually wrap up the session. And I will also share my a feedback form. All right. So if they can fill the feedback form, we will be sending the participation certificate to them as well. And let me share that link. Give me a minute. So I request everyone to fill the feedback form given in the chat box, right? And please write your name clearly so that we can actually send you the certificates of the participation, right? Along with that, I'm also sharing, just give me a minute. I'm sure most of you are already connected to me on LinkedIn. If not, please use this link to connect to me on LinkedIn as well, or visit our website proskillstrainings.com. Right, and let me request everyone to fill the feedback form as well. Okay, so right, so Nagaraju was saying something. So Hemant says, but the concept was in 2000 MOCN, which leads over and started. Right, okay, that's little too fine into the details, Hemant. We are just talking about these things that are very 6G is expected in. Okay, so there is a question from Carlo. Can we expect a merging ORAN specification and 3GP specification? Carlo, as of now, I don't see any hints, something similar to this, where we can try to merge the specification for the ORAN Alliance and 3GP specification. ORAN Alliance is a very minute part of the overall 3GP specification. And in the near future, I don't really see anything happening in that particular direction. Another question from Carlo, which says, today we have many challenges and alliances, Cloud RAN, AI RAN, etc. How do you see the presence of OpenRAN today in the market? Can we expect a better participation of OpenRAN in the market? Carlo, as I mentioned, the current industry, the current status of the overall telecom industry is in the downtrend. Not only the OpenRAN, even the 5G is seeing very little traction. We are considering even 5G as a failure, right? So there are companies who talk 5G as a failure, but the kind of experience, the kind of data rates what 5G gives are enormous, right? I see that, in the coming years, in a couple of years, and today is the time when we start actually doing the things related to OpenRAN. I see not only Mavenir, but many Mavenir's coming up in a couple of years who may target for OpenRAN kind of market share in terms of OpenRAN in 6G network, right? So any other questions? Let me. Okay, it says link not accessible. Okay, Chef, can you just try if you are able to open the link, or it creates some problem?
Yeah, it needs access. It is requesting for the.
Okay, give me a minute. I don't know.
This is the toughest question actually.
Give me a minute, because I opened this form just like that. Recently, Google have changed few things in their forms. That may be one of the reason. Okay, give me a minute.
Thanks to you, Nagaraju,
Yeah.
for joining.
Okay. So, Chef, can you please check if you can open this form now?
Yeah, now it's accessible.
Okay. So I request everyone to access this new link and then fill the feedback form, and we will be sending you the certificate. Please write your name and your email address clearly so that we can send you the certificates for the participation. Right. Any other questions? So I think we have already extended time by 10 minutes. If you have any further question, Sharaf has dropped his email address in the chat box. You can feel free to write an email to Sharaf or maybe send a message to me on WhatsApp. Thank you for joining in. I hope you enjoyed the session. For any future questions, please feel free to get in touch with me. Yeah, thank you very much. I request everyone to fill the feedback form. Thank you very much. Thanks, Sharaf. Thanks for your organizing the session and keep in touch. Thanks a lot.
Okay. All right, guys. Have a great day.